plus 3x
Minus?
8
Minus 8?
equals 0.
Good. And what are we asked to do other than solve? Is there a particular method they want us to use or just anything?
So it was one that was like a method of your choice.
Okay then. My choice is quadratic formula. Negative 3 plus or minus b squared minus 4ac times 8 over 2a. So x will be negative 3 plus or minus, this is 32, plus 9 is 41, the square root of 41 divided by 2. And there is nothing else I can do. Yes?
If we do it the long way and put -3 and the secant squared.
Oh, that's fine. That's fine. It's the same thing. The reason why I don't do it, because when I show you with the graphing calculator, if you forget one of those parentheses, then you're not getting anything. So once I know that there are two negatives in there, I will always change to positive. But yes, you can put as many parentheses as you need. As long as they are correct, that's fine. Is this okay?
Yeah.
Perfect.
I just wanted to make sure it's right.
Okay, very good. Anything else? Other questions? Anything else? Anything else? So we're trying to finish 1.6 and 1.7 today and start chapter 2 on Wednesday. Our first test is scheduled for the following Wednesday, but I don't think we can, so I'm going to have to postpone it for the following Wednesday. Okay? Well, we'll see. Yes?
Ma'am, just a quick question.
Yes.
And maybe I'm missing it. Isn't it supposed to be -8?
Yes, but the formula has a negative in it. It's minus 4ac.
Oh, so you just changed it across.
Already.
Okay.
Yeah, I don't want to put too many parentheses.
Now I see it.
Just for simplicity. When I see two negatives, I don't have to, but you can. You can write -4 times 1 times -8, but why if I have here 4 times 8 or simply 32? But it's up to you. Do not change your style to my style unless you think, oh, I think it's easier. But if you don't think it's easier, do not change your style to my style. What's the point? If it works, don't change it.
You said not this Wednesday, the next Wednesday.
I'm sorry?
You said not this Wednesday, the next Wednesday.
It was not scheduled for this week anyway. I'm talking about the next Wednesday, the following Wednesday, next week.
Okay.
It was scheduled for next week, not this week. So initially it was scheduled for the following Wednesday, not this week. But I don't think we're going to be able to finish the material and review it. Because I always use a session to review before a test. I can do that. I can finish material today and give you a test next time. I can do that. I mean, I can, but I won't. Okay, so let's go back. Any more radical equations, or are we okay? I'm sorry? We are okay with radical equations? Awesome, great. So now the next in line is equations with rational, same things, different word, or fractional exponents. Okay, so let's first review one thing. If I'm told x to 3/2, what does this mean? Oh, Victoria, we didn't even talk about that problem in class.
Oh, the one.
The one we just talked about. Yeah, we didn't. This is the first time I'm presenting this. So that's why I'm sorry.
Isn't it like x times 2?
No, because I said, well, why don't you use the method we did in class? But now I realize that we haven't gotten to it. I'm sorry, my apologies. Say it again.
I'm just trying to think back. X time or x something over 3. Oh, that's you. No.
Square root of x equals u.
Yes. So this is the square root of x to the third. So the formula is the nth root of a to the m. This is m, this is n, means a to m over n. So the index is always the denominator, and the power is always the numerator. Yeah, it just hit me as. Okay, so what about x to 1/4? What will this mean?
X. Well, I don't know what that is.
The fourth root of x. What about the square root of x? What is that? X to which power?
1/2.
Exactly. So here's our note to ourselves. Fractional or rational exponent represents a radical, and vice versa. So when I see a fractional exponent, it means a radical. When I see a radical, it means a fractional exponent. So keeping that in mind, let's look at problem 32 on page 185 that has x to 3/2 equals 27. Well, Victoria can teach this now. Yes, you can. Okay, so I recommend the following method. There are several methods, and I want to show you the one in the book. I don't disagree with it. I think it's way more difficult. They are asking you to memorize this on page 179. You can. I'm fine. If you want to do that, go ahead. Instead, I have a shortcut for you. And the shortcut is, and you will never make a mistake if you use this shortcut. First, remove the denominator. What denominator? This one. So first remove that denominator from the power. How will I remove that denominator? What should I do to both sides? Yes, of course, and we've done that in the previous, solving the previous equations, right? Now, one thing I want to ask you. You could say to me, and I will have to agree with you, what are you talking about rational or fractional exponents when you already told us a fractional exponent is a radical? Why don't you call this a radical equation? Well, forget about it. So what's all this? What do you need equations with rational exponent? Well, that's a radical equation, right? So, well, however, they are slightly different. They are slightly different than simple radical equations. Okay, so we're removing the denominator by squaring both sides, as you said. Awesome. So this is x cubed equals 27 squared. And now you're telling me, okay, in the next step, you're going to remove the power. So first, I remove the denominator, and then remove the power. If you keep these two in this order, always, you will never make a mistake on such an equation.
That's an exciting class.
First, remove the denominator, and please don't join them. First, remove the denominator and then the numerator. Okay, so how do I remove this numerator now? Of the power, of course. Yes. Remember, the cube root does not have two options. The cube root has only one option. Because remember, yes, please.
So you want the whole number, or is this fine for when you do the test?
So first of all, we have to write x equals. And this, we have several ways of determining it, and I want to show you a few. What I would do, because I don't really care for calculators, but that's a different story, I will change this 27, the cube root of 27 squared into this. I know it's 2 over 3. I will change 27 into 3 cubed. I will simplify when I multiply, and I will get 3 squared, which is 9. But that's my option. And there are two other options with the graphing calculator. So with the graphing calculator, you will put in 27 in parentheses, and the power, and in parentheses for the power 2/3. and you will get 9. Another option is to go to math, scroll down to the number 4, which is the cube root. So 4, the cube root of, and in parentheses, you know me now already, squared, close the parenthesis, and you still have to get 9.
So on the test, you want to simplify.
Oh, you have to. I'm not going to tell you that I have in my pocket the cube root of 27 square dollars. Right? I will tell you I have $9. So here you have either with the power 2/3, or, right? Power 2/3, because that's what it is, or you use math and the cube root of 27 squared. But yes, you have to simplify it. Any questions? Any questions? Okay, let's look at 38. Since we squared both sides, of course, I have to go back and check. Remember, we use this principle of squaring both sides, and I have to go back to check. How do I check? I plug in 9 to 3/2. But 9 to 3/2 is 3 squared to 3/2. When I multiply the powers, I get 3 cubed, and of course I get 27. So I would say yes. Not that one, this one, x equals 9. I would say yes. Okay? We always have to check. Here's the next one, 38. Same page, 185. X plus 5 to 2/3 equals 4. Again, if you stick with my method, you'll never make a mistake and you don't have to memorize anything other than removing the denominator first and then the numerator. So how do I remove this denominator first? The denominator in the power, of course. Yes, I have to cube both sides. And then I get x plus 5, everything squared, equals 4 cubed, which is 64. And now I know what to do next. And what will that be?
Square both sides.
Say it again.
Square root both sides.
Yes, apply the square root to both sides, but now I have to remember what to do. This is very important now. We've solved these equations. They are quadratic. That was method 2. Bless you. Then thank you. Thank you. You cannot get credit. Remember, please. That's why I asked, is it quadratic? Is it linear? So you know what to expect, right? So then we have x equals -5 plus or minus a. That's why we have two solutions, -13 and -3. So careful on that. Yes, we raise both sides to a third power, but it's the third power. Both will work. And we can check in x plus 5 to 2/3 if that equals 4. Okay, I can do it by hand like I showed you a minute ago, but also we can do it with the graphing calculator. How? So we have x, so I'm checking -13, parentheses, -13 plus 5, close the parenthesis, power, my choice is 2/3. It's up to you what you want to use, it's fine by me. And the answer is 4. And I repeat, and I replace -13 by -3. And the answer must be 4.
You kept the negative.
I did something.
You kept the negative. You kept the -3.
It is positive 3. Correct, correct, correct. Thank you. Thank you. That's why.
Yes.
Very good. My apologies. Easy to catch mistakes when you know what to expect. If you don't know what to expect, then you may copy that. I hope that that's not the case. Good. Okay. Any questions on equations with fractional or rational exponents? So remember what I recommend. You use the method you like. But what I recommend is remove the denominator of the power and then the numerator.
Can
Do
we
it.
do another
Yes.
that shortcut?
It's the same method. We apply the same method twice. I just want to make sure that that's clear.
Okay.
You understand? I will do a third one, but is that clear? I did not change the method on you. Is that clear?
Yeah.
So we remove the denominator first, and then we remove the numerator.
Yeah.
Okay, I just want to make sure that that's clear. Then we remove the denominator first, and then we remove the numerator. Okay, so we want to see a third one?
Yeah.
Okay, very good. Would you like to choose, or do you want me to choose?
Oh, you can choose.
Okay, so let's say 37. Same page. X minus 4 to 2/3 equals 16. Okay, so what type of equation is it? Okay. It's an equation with rational or fractional exponents. Is that okay? Okay, perfect. So then, what do we do? Yes, we have to take both sides, raise both sides to the third power. So we have x minus 4 squared equals 16 to the third. You can leave it as is for now. What will be the next step? Very good, awesome. How many solutions we expect? Excellent. So then x minus 4 equals? Excellent. The square root of 16 cubed, and we have to move 4. I would have never done that. I would have simplified it before writing it, but let's do it with a calculator if that's what you want. Any questions so far? Are the steps clear? Perfect. So you can plug it in, and it will be 4 plus the square root, and in parentheses, that's me. It doesn't read it right now, but you know me already. Okay. And then you copy with second and entry, or enter. That's what it says here, entry. And just replace. It's a bit more difficult for me to go back, but it's easier for you. And override the plus into a minus, and you get negative 60. So the answer are x equals 68, x equals negative 60. And you can go back and check them, please. Any questions? Is this okay? Yes? Everyone? Are you with me? Okay, perfect, perfect. Thank you. Okay, the last two types. We have to look at equations quadratic in form. Equations quadratic in form. What does it mean? Well, at the bottom of their hearts, they are quadratic, but they're not quadratic. But they can be replaced by a quadratic equation with the correct substitution. So we're going to use a substitution. Use a substitution. Ready? Okay. Let's take a look at first example. Let's say 42. X to the fourth minus 13x squared plus 36 equals 0. Can anyone identify this equation for us?
X minus
Yeah, yes, but what type of equation is it? Say it again. It doesn't have x squared.
Well, we can reduce
The-
it to x squared.
This is not this degree is not 2. So when this degree is 2, then it's quadratic. But since this degree is not 2, we cannot talk about quadratic or linear. What is it? Excellent. Degree? Degree 4. How many solutions? But it's fine. Everything is good. However, I'm having difficulties with this equation. It is polynomial, but what we've seen before with polynomial equations, they normally have 4 terms and we factor by grouping. That's not the case here. I also noticed something else, and this is not for all equations. So not all equations are quadratic in form, not all of them. But if I notice that this piece can be denoted by y, this is y. Let's look at this. If this happens to be y squared, I'm in business. But if it's not y squared, then I can't use this method, which means the equation is just polynomial. It's not quadratic in form. So if I denote this piece by y, do I get this as being y squared? Yes, because if you squared x squared, what do you get? X to the 4th. You copy the base, multiply the exponents. So then I use the substitution. This is my substitution. And you could say, why are you using a substitution? I'm using it only when it makes the equation easier to solve. Otherwise not. I'm not going to use it. But in this particular case, the new equation is y squared minus 13y plus 36. And this is something I know how to factor. This one I'm having some difficulties. Question, how do I factor this? And now I have to say that this is a trinomial. Is it in descending order? Greatest common factor? No. Negative leading coefficient? Special product? Of course. So it's y minus 6, everything squared. But what is the middle term here? Middle term. Please give me the middle term of this expansion. Negative 12. Not just negative 12, right? Correct. Is this negative 12y? So this doesn't work. So I have to continue. Is 1 the leading coefficient? Good. So then I know how to factor it. Not a big deal. But I cannot skip to check the special product. That was the point I was making here. Please do not skip the special product. Okay, so then what do I have?
What would
Y
be,
plus 4.
No, like y minus, because
Y
you have
minus
to
4,
positive
y minus 9.
Good. So now we have 2 solutions in y. And I know what you're thinking. Who cares about y? Well, we do. And you'll see in a moment what happens next. So 2 solutions for y, and one of them is, and the other one is correct. But now this is a new equation. And this is a new equation. Can anyone tell us what is the new equation?
4 squared.
What is this?
X squared.
Very good. So x squared equals? Good. What is this? That's it. Remember how many solutions we expect?
4.
Good. So which method would you apply to solve these 2 equations? We have 4 methods. Which one? Which one will I use? It's already set up and there is only one. It's already set up for that particular one. It's already completed. It's already completed. What will you do? Exactly. Of course, it's already completed. The square is already completed. It's that specific one that, can you use the quadratic formula? Yes, but it will take you 5 minutes and there is no need. Can you factor? Yes, you can move forward to the other side and factor, but why? That's exactly the method of taking square roots. So can you give me the solutions? We just talked about it a second ago. I asked again,
Plus
how
one.
many solutions,
Plus one.
and it's quadratic, how many solutions we expect?
Plus one minus two.
Very good. It's we tend to forget. I completely understand. I'm trying to be funny if I can, so maybe you will remember this. So that's why from the very beginning I established how many solutions. I saw that 1 second. I established how many solutions from the very beginning so I don't make a mistake. Yes, please.
So would it be okay, like, if we just wrote x plus 2, or x equals 2, and then x equals minus 2?
Of course, you can separate them. Of course. There is no need, but it's the same answer. Yes, absolutely. Any questions? Any questions on the method of substitution? Let's look at another. Please bring anything that you see in my math lab. If it's something that we haven't covered, please bring it to class like we did before. Always. You're helping me because there is no way I can choose every problem and every different problem. So please. 56. Same page, 186. So we have x plus 3, everything squared, plus 7 times x plus 3 minus 18 equals 0. What do you think about this one? What type of equation is it? If you say polynomial, I agree. If you say quadratic, I agree. Because x plus 3 squared will have an x squared, right? If you say quadratic in form, I will also agree. So it fits 3 categories: polynomial, quadratic, and quadratic in form. What will you denote by and what? It doesn't matter. Let's say t. Let t be, if it works, if the method works. If you look at this equation, what will you say? T is?
X plus 3.
Indeed. If I denote this by t, I can proceed only if this is what?
T squared.
Yes, if it's not t squared, I cannot use this method of substitution, which means the equation will not be quadratic in form. And you can say, wait a minute, why did you just square that and then add everything and subtract and combine like terms and then just factor? True, you can, of course. But I wanted to illustrate this method and how useful it is. I consider it useful. I hope you too. So what is the new equation? So since it's a quadratic, how many solutions do you expect?
4.
2 solutions. Quadratics have only 2 solutions max. Good. So can anyone give us the new equation then?
T squared plus 7t minus 18 equals 0.
Perfect. I have to drink, otherwise I stop coughing. I don't know why if I talk too much. 7t. And I know that this is not too difficult. So if not, I will use the quadratic formula.
Plus 9.
Good. So we have 2 options in t. Again, you can say, who cares about t? Well, we do, and we're going to get to x in a minute. And we have t equals, excellent. But now this one is a new equation that I have to solve, and this one is a new equation that I have to solve. Can anyone create the first equation for us?
-9 plus 3. Right?
So what do I have here? I have some. But why? It says let t be x plus 3. Why would you replace this by something squared? T is x plus 3. You can't do anything else. You can put a squared in there or anything like that. You can only replace t by x plus 3. There is nothing else. So the first equation is x plus 3 equals negative 9. Can anyone give us the second equation?
X plus 3 equals 2.
Right. You can make things up. You only have t, right? It's not t squared. It's just t. And t is x plus 3. So therefore, x equals negative 12 as the first solution, and x equals negative 1 as the second solution. And that's it. Is it clear what I was saying? You can just, from this equation, you cannot just do whatever else you want with t. You can only replace it by x plus 3 to find x. Does it make sense? Okay, do we need another, or is it clear? Another. Okay, very good. Okay, so let's look at 58. X squared minus 2x, everything squared, minus 11 x squared minus 2x, and plus 24 equals 0. And then we have one more type of equation. You will say let y, any variable but x.
X squared minus 2x.
Of course. What type of equation is it other than quadratic in form and polynomial? What is its degree? Very important to establish that from the beginning so I know. Careful. We have x squared squared. 4. So it is degree 4 and then 4 solutions. So please remember, somehow we have to come up with 4 solutions. Very good. Awesome so far. Can anyone dictate the new equation, please?
Y squared minus 11y plus 24.
That's it. This is an intermediate step. We use the substitution just to make our life easier. And then this can be factored. And how do I factor it?
Negative 8, positive 3.
So y minus 8 and y minus 3. So then we have 2 options for y. Again, if you're thinking, who cares about y? We do. And the 2 answers are?
3 and 8.
Okay, awesome. We are only solving quadratic equations here. There's no plus or minus yet. Good. So now this is a new equation. This is a new equation. Can anyone dictate 2 new equations that we need to solve?
X squared minus 2x.
Awesome. And?
X squared minus 2x equals 8.
Excellent. I think we got it. So then x squared minus 2x minus 3 and x squared minus 2x minus 8. And please give me the factored form. And how many solutions again?
4.
Awesome. Great job. Can anyone give us the factor form?
Negative 4, oh, sorry, wrong one. Negative 4, negative, positive 2.
And then negative 3 and 1.
4 solutions as expected. Negative 2, negative 1, 3, and 4. Great job. They look a little bit messy at the beginning, right? Until you get used to it and the substitution and you go back to the substitution. But initially they look, yeah. But it's not really, yeah. Okay, so the last type of equation is absolute value equations. For now, later on we'll have 2 more equations, the exponential and the log equations. But this is the last one for now. Okay, let's look at a very, very simple example. This part is the distance between x and 0. So it must be always a positive number. So on this side, we have the absolute value of x. On the other side, we have 2. The equation is really asking us to find x whose distance from 0 is 2 units.
That was V X minus 10
Yes,
negative 2 plus 2.
correct. That's it. I cannot say anything else. Very good. Now let's practice. There's nothing else to it. Let's take a look at 67 on page 186. Twice 3x minus 2 equals 14. I would like to write together with you a note. The absolute value symbol is not a grouping symbol. The absolute value symbol is not a grouping symbol. What does that mean? You cannot distribute, you cannot take things out.
Does that mean that 2 is only affecting the 3x?
It doesn't affect anything. It's multiplied outside, has nothing to do with the absolute value. So this equation has to be cleaned up to look like this before I decide what to do. So what will you do? It's multiplied. If it's multiplied, I cannot break the product by moving to the other side, but how can I break it? Indeed, that's the opposite operation. The reverse operation, I should say, better. Okay, awesome. So then you will say 3x minus 2 in absolute value is? Great job. So now let me take you back to the simple example we had. We said, what numbers go here? Oh, well, 2 and negative 2. I'm going to ask you the same question. What numbers go in here? Or, that's it. All you have to do is just mimic what we just did. But of course, assuming you understood it. I don't want you to mimic anything. I want you to understand it so you don't forget it. So the inside could be 7 or negative 7, obviously. So 3x, I move 2, I get 9. 3x equals 9, therefore x equals 3. On the other one, we have 3x equals negative 5 or x equals negative 5/3. Another note I would like us to write, and the note would say, every time I see an absolute value somewhere, I should always think that it has 2 different options. There are 2, most of the time, 2 different options. Absolute value implies 2 options, most of the time. Let me give you an example in which you only have 1 option. What can this be?
0.
Only 0. This is x minus 1 equals 0 or x equals 1. Here is another contradiction of my 2 options. What do you think about that one? It does not work. How come that this equation has no solutions? Because the distance cannot be negative. Indeed. I would like to, before we finish with 1.7 tonight, I would like to look at a word problem. I always try to fit in at least one, so you see the connections and why do we do this. Ready? Let me know if you have any questions so far, please. Stop me anytime for questions. Is this okay? Yes, please.
No solution because it's a negative 3.
There is nothing. Yes, because I'm saying find numbers whose distance from 0 is negative 3 units. I cannot say that the distance between me and you is negative 10 feet. So if the distance is a negative number, obviously there is a contradiction. Yeah. Okay, very good. So let's look at the word problem. So I like to look at this graph. Here it is. And it says the graphs show the percentage of jobs in the U.S. labor force held by men and women from 1970 to 2015. Exercises 109 and 110 are based on the data displayed by the graphs. So it doesn't matter which one we look at. The one problem is for men, jobs that men held, and the other one for women. So it doesn't matter. So let's do 110 because I'm assuming you're going to do 109 and it has the answer in the back. So I think that that's okay. Ready? So I'm sorry.
What page is that?
Oh, I'm just writing right now.
Okay.
I will not forget. Yes, 187. So we are given a formula, P equals negative 1.6 the square root of t plus 62. Models the percentage. So I'm taking notes. This is the percentage of jobs in the U.S. labor force, P, held by men, T years after 1970. T years, which means T equals what for 1970? 0. T years after 1970 means 1970 represents 0. Use the appropriate graph at the bottom of the previous column to estimate the percentage of jobs in the U.S. labor force held by men in the year 2010. So my first part is 2010 from the graph. Read from the graph. For 2010 for men. Okay, so let's look at the graph again. For 2010 for men. Obviously, it's very difficult to read. I don't know what this is. It could be 52, it could be 51, it could be 53. I would say 53, 52, whatever you want. But a reasonable estimate. Would you say 53?
Sure.
Okay, so let's say 53. So from the graph we have P equals 53%. Part B. Use the mathematical model to determine the percentage of jobs in the U.S. labor force held by men in 2010. What do we do now? Still 2010, but now from the model, from the equation. That's what it means. So what do we do?
You're looking for a percentage,
Yes,
so you would be 40.
excellent. Good. So then what is the next step? Exactly. Negative 1.6, the square root of 40 plus 62. So let's put in the calculator. So we have negative 1.6, the square root. Go outside of the square root plus 62. And we get 51.9 approximately. 51.9%. So this is what the model is giving us. The actual value determined was 53. Would you say that this is an underestimate of the true value or an overestimate? Yes, of about 1%. Okay, about 1%. According to the formula, that's part C now. According to the formula, when will 49% of jobs in the U.S. labor force be held by men? What is this now? What is this given? Indeed. Can anyone dictate what I have to write next? Yes. Yes. Awesome. Very good. Very good. So this is a perfect example of what we just are discussing in this section. What type of equation is it? And we have a long list now. linear, quadratic, rational, absolute value, radical, polynomial, rational exponents, quadratic in form. Which one is it? Is it a ratio? Is there x in the denominator for a ratio?
I don't know.
No. So, what type of equation is this one? Of course, there is nothing else but just a radical of x or radical of t. Of course. This is a radical equation. Excellent. How do we solve it?
Take the outliers out, so take the
Yeah, so I'm going to move this here and that here because I want a positive situation. So 62 minus 49, I think it's 13. How do we solve this? Anyone? Yeah, so we could divide first. That's fine if you want to do that. I agree. I normally don't divide if they don't divide evenly, I don't divide in this situation, but that's not wrong. It's perfect. So what now? Of course. Of course. So then t equals that number. So I'm going to plug it in. So I have 13 in parentheses. 13 divided by 1.6. Close the parenthesis and square the answer. Okay, so 66. 66, what does it represent? 60. Yes, indeed. Since 1970, and that will be 36? Great job. Very good. Was it similar enough to the first problem we worked on? Awesome. Good. Last section. Linear and absolute value inequalities. Last section before we start chapter 2. Linear, absolute value, inequalities. See you on Wednesday, Victoria. Good luck. Okay, let's start with linear. I'm sure we remember this, but we have to look at one or two. So let's say 5. 3 minus x. I'll copy in a moment the page and everything. So this is problem 40 on page 203. This is also a review, and we're going to review interval notation as well in a minute. Ready? What would you recommend?
bring the distribute the 5.
Excellent. So 15 minus 5x less than or equal to 3x minus 1. Like solving linear inequalities, similar to solving linear equations, except the symbol and except the final solution will be totally different. So then we have negative 8x less than or equal to negative 16. Now we have to be careful, and we have to remember something very important.
If you divide by a negative number, you have to switch the...
If we divide both sides or multiply both sides of an inequality by a negative number, we remember that. So is 2 less than or equal to 3?
Yes.
Good. Let's say we multiply by negative 1. Can I still keep the same inequality symbol? No. So please remember, every time we multiply or divide both sides of an inequality by a negative number, we have to switch the symbol. If it was less than or equal to, it becomes greater than or equal to, and so on and so forth. If it's greater than, it becomes less than. Are we okay with that?
Yes.
Okay, perfect. So then what do we divide both sides by?
Negative 8.
Good. So then I have x and I have 2.
X is greater than 8.
Perfect. So here's the interval notation for you. We're going to graph this one, and anytime you want me to graph, I will graph. But 2 to infinity, we don't care for units. I'm using a bracket because of the equal symbol. Every time there is an equal symbol, I have to use a bracket. For infinities, is always parentheses. Always. So in interval notation, the solution is 2 comma infinity. I like to write before this x in a number in the interval blah blah blah, or in short, x in 2 comma infinity. You don't have to, but when we get to, for example, 2 comma 3, 2 comma 3 looks like an ordered pair. But if I put in front x in, you know I'm not talking about an ordered pair, I'm talking about an interval. So that's why I recommend writing that, but it's up to you. Let's look at one more, like 46. Same page. And we have 4x minus 3 divided by 6 plus 2 greater than or equal to 2x minus 1 divided by 12. The reason why I would like to look at this is because some of us are still afraid of fractions, and I don't want you to. I don't want you to be afraid of fractions. Please don't. What would you do here to eliminate them in a blink? Both sides by? That's it. So please don't be afraid of fractions. Okay, so 12 over 1 times 12 times 12 over 1. Like we did last time and before, do not multiply. Please simplify. So 6 and 12, 12 and 12. When you're ready, I would like you to give me the new equation. Yes? Let's write it first without distributing. Plus 24 greater than or equal to, for everyone to see this stage first. Madison is always ahead of me, which I love.
This time.
Oh, you're finished my math lab. Is there
Yeah,
any?
that's the only
is there
reason
any-
I get this is because I did the homework ahead and I had to teach myself it before you actually taught it.
Okay, if it works for you. I have the videos from last semester if you want to watch them.
No, I'm good.
Okay. No, they're there. No, they're there. They're posted in Canvas.
All right.
Okay, so this is 8x minus 6 plus 24 greater equal to 2x minus 1. Or 8x plus 18 greater equal to 2x minus 1. And then we move terms around. After we completely simplify as we did with all linear equations. Although this is not a linear equation. So finally we have 6x greater equal to negative 19. Or x greater equal to negative 19 sixths. In interval notation, negative 19 sixths to infinity. X in the interval.